Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In a previous video, we showed the intuition behind the log-log model and we said that the beta 1 is an elasticity. In these videos, we're going to prove that more formally. So we're going to start as usual from the population model. So we're going to have ln of y being equal to beta null plus beta 1 ln of x plus an error term. We're going to assume that the conditional expectation of the error term on x is equal to 0. And we're going to take the conditional expectation in here on both sides. So the expectation of ln of y conditional on x is equal to simply beta null plus beta 1 ln of x, and keep in mind that the conditional expectation of the error term on x is 0. That's why it no longer shows into our population regression function. Now let's take the derivative with respect to x. So we differentiate with respect to x. Normally we would have a derivative of this entire expression with respect to x. And in the right-hand side, the only bit where we see an x is in here, so obviously the beta null will disappear, and we're going to have simply beta 1 times the derivative of ln of x, which is just 1 over x. So basically, like we can rewrite then the left-hand side simply as the derivative of the ln of y with respect to x being equal to beta 1 times 1 over x. Now, we're going to use a concept that we have seen quite often in the previous few videos, and that is, recall that the derivative of ln of y with respect to x, okay, is simply 1 over y times dy over dx, okay? If we rearrange this expression a little bit, then we will have 1 over y times dy over dx being equal now, because this expression is exactly the same in here, okay? So we can substitute. So that means that the two right-hand sides are equal to each other. So this is beta 1, 1 over x. Multiplying both sides with x, we're going to finally get that x over y dy over dx being equal to beta 1. And this is the key moment we were waiting for, like, to end this proof, because notice in here, the left-hand side that we have, so this x over y dy over x, that is literally the definition of elasticity. Definition formula. Okay. Which means that the elasticity is equal to beta 1. All right, so the slope coefficient is literally the elasticity. Now, why elasticity is constant? Linking it back to the intuition that we saw in the previous video. Look very carefully on your right-hand side. You only have a beta 1. You don't have an x. So it means that there is no x left in the final expression, and elasticity does not depend on that level of x. Okay, that's why the log-log model assumes constant elasticity. All right. If you remember from the video in which we introduced also the properties of the log function that we like so much, any changes in the ln of y approximately where delta y, so changes in y over y. and at the same time, any changes in the ln of x approximately would have been delta x over x. So that means that if you simply have a log-log model, you can write it in terms of changes, as any changes in your ln y would be equal simply to beta 1 times the changes in your ln x, okay? So percentage change in y equals beta 1 times percentage change in x. All right. So one sentence key takeaway here is, in a log-log model, beta 1 is the constant elasticity of y with respect to x, and this was just a formal math proof to that. I hope this was helpful, and I'll see you in the next video.